start testing. 7 and 4.
Are we having 2 quizzes this chapter?
Just one. All right. So today we're going to start talking about matrices. We're going to essentially what we're going to do is turn our system of equations into a matrix, and then we're just going to do exactly what we did before but with a matrix. But first let's figure out what a matrix is when we say a matrix. A matrix is just a rectangular array of numbers.
Does it have to be rectangular?
Yeah.
Mm-hmm.
That's why it's part of the definition.
So we set up our numbers in rows and columns, so we get a rectangular array of numbers. We call the numbers elements. And our notation for the elements are A is just some number, and you put a subscript ij. The I tells us what row it's in, and the j tells us what column. So for example, if it said, if we're talking about A sub 2, 4, this is the element in row 2, column 4. Yes?
Is there anything separating them?
No.
So it can only go to 9?
Well, if it were a 2-digit number, we would have to do something like A2 and then kind of a space and 17 to make sure that you know that you're talking about a 2-digit number. But we're going to use small enough arrays or matrices where we don't have to worry about it. The size of the matrix, or the dimensions of the matrix, are the number of rows times the number of columns. We usually write m times n. And this tells us how many rows, and this tells us how many columns. So we say a 2x2 matrix, a 3x2 matrix, and that's talking about the rows and the columns. A square matrix is just n by n. Same number of rows, same number of columns. Same number of rows as columns. The other thing the other way you'll hear the dimension of the matrix referred to is the order of the matrix. So you could say a matrix of order 2 by 3, for example. And this will come up a little later, but if we had something like this, A11, A12, A13, dot, 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 we call that a row matrix. And if we go the other way, A11, A21, A31, this way, we call that a column matrix. And we'll deal more with specific types of matrices later when we start talking about matrix operations. All right, so what we're going to do today is take a system of equations and turn it into a matrix. And then use our row operations on the matrix rather than on the system of equations. So we're getting rid of the variables, kind of cleaning up the way we write it all out. So is everybody good with the idea of a matrix and how we talk about a matrix, that kind of thing? Okay. All right. So if we have a system of equations, for example, we have 2x plus 3y minus z is 4, x minus 2y plus 3z equals 8, and I'll say a 3x plus z equals 5. So that's our system of equations. We're going to translate that into a matrix, so we're just going to write the numbers. So the matrix would be 2, 3, negative 1, 4, 1, negative 2, 3, 8. 3, if I'm missing a variable here, I'm going to put a 0. 1, 5. And sometimes you'll separate this with kind of a dotted line. We call the part here that's just the numbers in front of the variables, we call that the coefficient matrix. And we call the matrix where we put the constants onto the side there, we call that whole thing the augmented matrix. So we augment the coefficient matrix with our constant matrix, and we get our augmented matrix. So this represents this system of equations. And we're just going to take this matrix and do our row operations on our matrix. So just as a reminder, our row operations. So instead of talking about what we do with equations, we're going to talk about what we do with rows. So we have 3 operations, just like we did with our system of equations. We can exchange 2 rows. We can replace any row by its multiple. So we're multiplying by a number and replacing the row with that row replaced by a multiple. And the number we're multiplying is not 0. If we multiply by 0, then the whole thing goes away. It doesn't help us. And then our last one is we can replace any row by the sum of itself and the multiple of another row. So we're doing exactly the same thing as we did with systems of equations. We can switch to equations. We can multiply an equation by a constant, and that doesn't change our value. And we can multiply an equation by some constant and add it to another equation and replace it with a new equation. So we're doing the same row operations that we did with systems of equations. And what we're going to do is do the same process. So we're going to do Gaussian elimination on our matrix to get the matrix into row echelon form. Yeah.
So I still don't understand step number 3. So you replace the row. So on the third row of our example, so would that be 4 or 9?
So what we're doing is we're replacing the row by the sum of itself and a multiple. So that's where we're saying I want to get rid of this 1 in this first place. So I multiply this row by -2 and add it to that row. And then write the new row that I get in its place.
Okay.
So we're just multiplying the row by a constant, adding the two rows together, and then writing down what we get in the matrix instead of the old row. Just like we did with the equations. I want to get rid of this x, so I multiply this by -2, add it to this one, and write down the new equation. All right, so all I want to do is go through an example of doing row operations, getting a matrix in row echelon form to solve a system of equations. Really not doing anything different than we did on Monday, other than putting our equations in the form of a matrix rather than in equations. Yeah?
When you add them, does it matter which row you do first?
No. No. But we kind of do this in the same order that we did with equations. So we want to get rid of these x's. So we want to get rid of these two numbers, and then we want to get rid of this y. So then same kind of idea. All right. So let's do an example. So I'm going to write the system of equations x plus y plus 2z equals 3. 3x plus 4y plus 4z equals 9. And 5x plus 2y plus 15z equals 13. So there's our system of equations. So some of your homework is just going to ask you to write the augmented matrix for the system. So if we were to let's write our augmented matrix first. So this turns into, I'm just going to write it, so this would be our augmented matrix. You can put the dotted line through there just to keep those straight. Sometimes you'll see it written that way, sometimes you won't. All right, and our goal here is to get our matrix now into row echelon form. So the idea that in terms of the matrix, we're trying to get those three numbers to be 0. Just like with our system of equations, we wanted to get rid of the x's, that's those two numbers, and we wanted to get rid of that y, so that's that number. All right, so I'm going to write it in a column over here. So the top row doesn't change, just like with our equation. We wrote that over and over. What we usually do is write the operation that we did next to the row that we've changed. So what are we going to do with these two rows? We're going to work with the first two rows to get rid of that 3. So what are we going to do to get rid of that 3 there? Multiply row 1 by -3. So I'm going to say 3 row 1 plus row 2. That's how I get this row. -3, sorry. -3 row 1 plus row 2. So when I do that, I get a -3 plus 3, I get a 0 there. -3 plus 4, I get a 1. -6 plus 4 is -2. And a -9 plus 9 is a 0. Now how do we get rid of this 5? We're going to use the first and last row to get rid of that 5. Multiply by -5, right? So I'm going to write -5 row 1 plus row 3. That's how I get this new row. All right, so I get a 0 there, and then I get a -5 plus 2 is -3. -10 plus 15 is a 5, and a -15 plus 13 is -2. And now we're going to use the second and third rows to get rid of that negative 3. So my first and second row stay the same. 1, 1, 2, 3, 0, 1, negative 2, 0. Yeah. If I tried to use the first equation to get rid of this negative 3, I would end up then with with a number in that position in the third row. And I want 0. I want to keep that 0 there. All right. So I have a 0 there. So what are we going to do now with these two? How are we going to get rid of that negative 3? Multiply this row by 3. So I'm going to say 3 row 2 plus row 3. That's how I get this new row. So I get a 0 there. 3 times negative 2 is negative 6. Plus 5 is negative 1. 3 times 0 is 0. And minus 2. And is this, we would be able to get our solution from this, is this in row echelon form? What? Yeah, we need to divide by negative 1 first to get rid of the negative 1, right? Yeah.
You multiply 3 times row 2 or row 1?
This one, row 2. Because we want to use these two rows to get rid of that 3. Because I want to keep that 0 there.
So from the
Second row doesn't change. After you do this first operation, the second row is not going to change. We're just changing the third row. Okay? So our last step would be for this to be in row echelon form. And what we did there was do negative 1 R3 to get it in row echelon form. So what we've done here is Gaussian elimination on the matrix. Just like we did Gaussian elimination on our system, we did Gaussian elimination on the matrix to get it in row echelon form. And now what we're left with is this tells us, now we retranslate that into a system of equations. X plus y plus 2z equals 3. Y minus 2z equals 0. And z equals 2. And then we can do back substitution to get x and y, just like we did before. So our solution, if we did our back substitution, what was 15? Right, but then when we got rid of this 5, when we did this operation, it turned it into a 5. Because I did negative 5 times row 1, so I get a negative 10 plus 15 gave me that 5. So our solution turns out to be, for this one, negative 5, 4, 2. If I do the back substitution.
Do we have to ever put it in the matrix if it's just easier just to do it?
Some questions will ask you, write the augmented matrix and then use row operations to solve the system of equations. Yeah, Alice.
So what we're trying to get to is having those 3 zeros with all the positives on the right.
Right. Well, that would be row echelon form. If we just needed to solve the system, we could have solved it from here because we could have negative z equals negative 2. But if we wanted to get it into row echelon form, we want all of these to be positive. Okay? Yeah, Ellen.
Is there a purpose to using this method as opposed to just like leaving it in the system?
Our main purpose is that we're going to start, we're going to do other operations with matrices. So it's just mostly it's just to get us used to the idea of a matrix. And we'll be doing other things with matrices. And if you do this method, it's a little cleaner than keeping the x, y's, and z's in there. You don't have that. You just have the numbers. You're just dealing with the numbers. So that it makes the notation a little more compact. And it's easier to write these here to tell what you've done to get the results, to get back to, so you can pick out where you might have made a mistake. So those are a couple of the reasons. But mainly it's just to get us used to the idea of working with a matrix. All right, questions there? Okay, I have one question for you guys.
Really? You're gonna do that?
So we have this parabola, and it goes through, we have this parabola that goes through the points 1, 6, negative 1, 4, and 2, 13. Yes. So here's the question. We have to find A, B, and C. What do we do?
You make those the X and Y's, and sometimes do that.
So Cole says, make these the X's and Y's. These are X's and Y's, right? What's that going to get us? A system of equations. So let's call this point 1. Point 2. Who was the psychic that predicted that? Was that Jack? Or was that Thomas? You said systems, Thomas? No? That was Jack? Oh, it was Macy? Okay. All right, so from point 1, this is an X and this is a Y. I get, if I plug in X equals 1, I get A plus B plus C equals 6. I'm just plugging in X equals 1 here. 1 times A plus 1 times B plus C equals 6. From 2, I get, if I plug in negative 1, I get A, negative 1 squared is positive 1, minus B plus C equals 4. Thanks, Mike. And then from the third point, if I plug in 2, I get 4A plus 2B plus C equals 13. And I have a system of equations, and I can solve for A's, B's, and C's. I can use row operations on the equations, or I could turn it into a matrix, use row operations on the matrix. And now it would let me find A, B, and C, turns it into a system of equations, and it would turn out that if you did that, you should get y equals 2x squared plus x plus 3. So A equals 2, B equals 1, C equals 3. Isn't that nice? All right. Homework.
Could this by chance be a bonus problem or something? Or is this just normal choice problem?
This possibly could be just a normal problem.
I gotta start parking, Mr. Green. You don't need.
Yeah, Tuesdays. I can't remember. I don't know the schedule.
Yeah, we have it.
So we probably should turn it in tomorrow. Otherwise, you guys will forget.
We should have
Treason against the land.
Well, it should be treason against Mr. Ming number 79.
What will probably happen, what should happen, is you should probably finish it in class today, and then you won't have any homework.
Is this doable to finish in
Yes.
class?
It looks so long compared to all the other assignments that we've had. You know, those have been long too, so the questions are really long.
No, some of these are just write the augmented matrix, some are, and number 67, in your book, number 67 says use Gauss-Jordan elimination. Just use Gaussian elimination. Gauss-Jordan elimination is way too much work to do by hand, I think. And then we want to do page
Oh, there's more.
501, number 77, and 79. These are the parabola problems. All right, there you go.
Mr. Mayor,